Planet Earth, structure. The structure of Earth is known directly through rocks from mining areas and volcanic eruptions, and indirectly by geophysical methods. Geophysical methods use technical applications and equipment to collect information about the Earth, oceans, and atmosphere that are not directly observable by our senses. Below are the methods and the instruments used. Advances in seismology and other related technology allowed us to learn a great deal about the Earth and the many layers that make it up. Each layer has its own properties, composition, and characteristics that affects many of the key processes of our planet. The size of the Earth, about 12,750 kilometers in diameter, was known by the ancient Greeks, but it was not until the turn of the 20th century that scientists determined that our planet is made up of three main layers: core, mantle, and crust. This layered structure can be compared to that of a boiled egg. The crust, the outermost layer, is rigid and very thin compared with the other two. Beneath the oceans, the crust varies little in thickness, generally extending only to about 5 kilometers. The thickness of the crust beneath continents is much more variable but averages about 30 kilometers. Under large mountain ranges, however, the base of the crust can be as deep as 100 kilometers. Like the shell of an egg, the Earth's crust is brittle and can break. Layers. Cutaway views showing the internal structure of the Earth. Below, this view drawn to scale demonstrates that the Earth's crust literally is only skin deep. Right, a view not drawn to scale to show the Earth's three main layers, crust, mantle, and core, in more detail. The table above shows dimensions, volume, and mass of each layer. Composition. Earth is composed of 4 layers, starting with a solid inner core at the planet's center, enveloped by the liquid outer core, semi-solid mantle, and rocky external crust. Types of layers. Earth's layers can be assigned according to the following. 1. Chemical composition, what they are made of. Core. Mantle. Crust. 2. Mechanical, physical, properties, rock strength and elasticity. Barosphere. Mesosphere. Asthenosphere. Lithosphere. Discontinuities. The interior of Earth is made of different kinds of materials. Each of those materials is different from the other by their physical or mechanical and chemical properties, for example, temperature, density, etc. In geology, the word discontinuity is used for a surface at which seismic waves change velocity. Also called the transition zones separating the layers. Layman discontinuity, there is an abrupt increase of P-wave and S-wave velocities at this depth. Discovered by a Danish seismologist and geophysicist Inge Layman. Gutenberg discontinuity, at this depth the P-waves of earthquake slowed down dramatically, named after Bino Gutenberg, a German-American seismologist. Rappetti discontinuity, the transition zone between the lower and upper mantle, discovered by William C. Rappetti, an American Jesuit priest and seismologist. Moho, or Mohorovičić, discontinuity, the boundary between the crust and the uppermost mantle. At this depth the seismic waves change velocity and there is also a change in composition. The boundary is between 25 to 60 kilometers deep beneath the continents, 5 to 8 kilometers deep beneath the ocean floor, named after the pioneering Croatian seismologist, Andrija Mohorovičić. Conrad discontinuity, the boundary between the upper and lower crust. The border where the density of silica-aluminum and silica-magnesium composition changes, a boundary within the continental crust that can be detected seismically at about 10 to 12 kilometers depth, named after Victor Conrad, an Austrian-American physicist, seismologist, and meteorologist. Like all bodies in our universe, the Earth is not a finished product, but a dynamic entity that is subject to constant change. And what we know about our world is still subject to theory and guesswork, given that we can't examine its interior up close.